This lesson is on simplifying radicals. When I simplify radicals, I need to remember all of the different rules about radicals. Again, one way to do this, and this is not the way that I typically do it, but I want to show you all of the different ways you could go about this, is I know that if I'm trying to simplify, I'm trying to see how many x's can I take to the outside. So just as I did before, I could break this down into a tree, and obviously I would end up with 9 x's in my tree. I would need, I'm going to go ahead and write all 9 of them. 4, 5, 6, 7, 8, 9. I know every group of 2 brings an x to the outside. So I have 4 groups, so that means x to the 4th on the outside. I have this one left over that doesn't have a partner, and that has to stay on the inside. So that's one way to do it, is to make the tree. Trees work great. Another way to do it is to break it down into 2 parts, knowing that one part will be divisible by that 2 and the other part will not. So the square root of x to the 8th is x to the 4th, with this one left over. The way that I tend to do it is this way, which is of course to take 9 divided by 2, which is 4, with 1 left over. So that leftover has to stay inside because it doesn't have a partner. So let's try these questions. Again, I'm going to use the method that I'm most comfortable with, which is dividing. So 7 divided by 4 is 1 with 3 left over. So b to the 3rd still on the inside, and then 4th root. 7 divided by 3 gives me 2 x's, but there's 1 left over. And then 9 divided by 3 gives me 3 y's with nothing left over. So that would be my simplification. And last one, 4 divided by 5, that does not reduce, so that's going to stay on the inside. So a to the 4th, 5th root. 10 divided by 5 is 2, so that's b squared. Nothing left over on the inside. 11 divided by 5 is 2, with 1 left over on the inside. Notice you keep the index the same as the original question every time. Here's more for us to try together. Again, now we're dealing with numbers as well as variables. So again, the 25, I can choose to make my tree of 5 times 5. I have a group of 2, so that 5 is going to come out, or I just know that the square root of 25 is 5. 4 divided by 2 is 2 with nothing left over. 3 divided by 2 is 1, but 1 left over. So 5x squared y, square root of y. My next one, 375. Again, this might be one where making a tree would be a better idea. 375 is 125 times 3. 125 is 25 times 5. 25 is 5 times 5. Again, you need a group of 3 things to come out. So there's a group of 3. So that gives me a 5 on the outside, but notice this 3 has to stay on the inside. So on the inside, we're still going to have 3. And then 6 divided by 3 is 2. And then 4 divided by 3 is 1, with 1 left over. So everything we can take out, we do. And then anything left over stays inside. Last one, again, just as we did before, if you have a fraction like this, I would go ahead and reduce that fraction before you take the square root. So in this case, I would say divide by 5. So I'm going to leave it inside the square root. I'm going to get 9 on top. If I divide this by 5, I get 16. I'm going to reduce. I have 3 x's and 1 x, which gives me 3 minus 1, or 2 x's. And then I'll reduce my y's. Y divided by y cancels out. So really, I'm taking the square root of this. The square root of 9 is 3. The square root of x squared is x. 2 divided by 2 is 1. The square root of 16 is 4, and so my answer is 3x over 4. Go ahead and try all of these questions on your own, and then press play to check your work. For the first, I could rewrite 32 as 2 to the 5th. That would help me as I move forward. So 5 divided by 4 is 1. So 2 to the 1st comes out, but I still have a 2 on the inside because there was 1 left over. 10 divided by 4 would be 2, but again, 2 left over. And 19 divided by 4 would be 4, and that would be 3 left over. So that would be my simplification. For my next one, 40 could be rewritten as 2 to the third times 5. 8 times 5 is 40. 2 to the third, the 3 divided by 3 gives me a 2 on the outside. Of course, that 5 is going to be stuck on the inside. 3 divided by 3 is 1, so x to the first. 5 divided by 3 is 2. I'm just kidding. 5 divided by 3 is 1 with 2 left over. That's the 2 I was thinking of. Just pretend that's not there. And then 7 divided by 3 actually is 2. And then, of course, I have 1 left over. So 2xyz squared, and then the cubed root of 5y squared z. And the last one. Before I take the cubed root, I'm going to reduce these. So 4 divided by 2 is 2. Or sorry, 4 minus 2 is 2, and so I'm going to rewrite this as the cubed root of x squared over 27. I can't take the cubed root of x squared, so it's just going to stay inside, but the cubed root of 27 would be 3, and so that's my final answer.